Okay, it's another day. I hope we've got our best minds with us today. We've got our minds sharpened up. I hope we had a great night's sleep. I want to tackle what do you call binary arithmetic. Now, the binary arithmetic. We're going to look at addition, subtraction, obviously the multiplication and the what and the division. Obviously, we have to start with the what with the addition. The addition. It's best for me to start with best 10 so that people can be on the same page as me. Let me try and see if I've got a clear picture there. I want to start with best 10 because this is what we've been normally, every time they say add, we've been doing best 10. So let's say best 10 addition. Let's understand a few things that we are going to need. For some things we've been doing in best 10 and taking for granted, now we need to be keenly aware of a certain thing, a few things, so that we can translate this, or rather transfer that skill to as easy as possible to the other bases. Let's take a number like 27. Let's say we add that to 16. All right. When you say 27 plus 16, what we're essentially doing is 27 plus 16. Traditionally we've been saying what 7 plus 6 is 13. And we say 3 carry 1, then we come and you say that 1 plus 2 plus 1 gives us 4. This is what we've always been doing, but what exactly does it mean? Let's try another way of doing this. Let's say 27 plus 16, but instead of saying what we're doing here, basically, essentially, we are actually adding 7 plus 6 on its own, and we are carrying 13 first. This is this is what we get from when we add the units. Okay, then when you add the tens, we place a holder here, and you say 2 plus 1, because this is the tens, but to show that we're taking the tens, we place a holder, say 2 plus 1, and this is 3. Then you say, okay, we still have, as long as we still have more than 2 lines, we're going to what? Oh, by the way, here we're dealing with the tens, so we place a holder there. Then you say, okay, now we still have 2 numbers. We want to end up with 1 number, so we repeat this and say, okay, the units, now they only give us units and we are happy, and then the tens give us only the tens and we are happy, and we've got the same answer. So what we're essentially doing is, what have we done here? We've added, when we added here, the units gave us a 3 still on the units, then a 10 was promoted. So what we normally call the carry this side, what we call the carry this side is actually a promoted 10 that is promoted from what? From the addition of the units. So we didn't carry a unit, we carried a 10, because the tens, the units went beyond went beyond the tens, the 10. So therefore we had tens in the units that we had ultimately. So we had to promote, we had to carry the tens over. So what did we carry? We didn't carry 1 like we normally say. We carried 1 set of 10. I think that is probably gonna make our life easy. Okay, let's try and do another example which is a bit longer. Let's say we've got 136 and we're adding that to 99. When we add, I will start with this long method to just to highlight a few things. Let me start with the units first. When I'm doing the units, it's gonna be 6 plus 9. It's gonna be what? It's gonna be simply 15. This is what the units give us, but the units are giving us tens now. All right. This is what we're going to carry later when we're doing it in a direct approach. Now I'm going to say, okay, let me do the tens. Let me add the tens. And with the tens now, what do? I have to place a placeholder there and do the tens, and it's going to be what? It's going to be 12. What have I carried here? I was working on the tens. Now I've got hundreds coming from what? From working with the tens. What does it mean? I've carried another set of 10, because I've carried 100 is 10 tens. So I've created another set of 10, which was 10 tens, because we were working on the tens. So we are carrying again another set of the base, because 10 tens. 10 is a what? Is a base. So we're carrying a set of the base. Now we go and say, okay, let's work on the what? On the hundreds. Oh, what kind of writing is this? Let's work on the hundreds. I hate it when I can't see what I'm writing. I hate it also when students write things that I can't see. So I put a placeholder on the what? On the units and the tens, because we're going to work on the hundreds. Now we only have that 100, so we bring the hundreds here. But we still have lots of numbers here, so we have to add again. Now when you do that, the tens, the units are not challenged. Now I'm dealing with the units here, so there's no challenge for the units. I can go on and do the what? And do the tens, and then they are giving me three of them again. There's nothing to promote, and now there's this 2 here that I can add, and they give me 2. If I had found 2 numbers here, if I was able to come up with 2 numbers here, I was gonna add again. But fortunate for us, that is the end, and this here is our what? Is our answer. Okay, so what I want to highlight here is that when we added the units, we carried a set of tens. These are units. When we added units, we carried a set of tens. Okay, this was a set of what? This was actually 10 units, so it was a set of what? Of the base. When we added these now, we carried what? We carried a set of the base, because it was 10. It can't have been 1. We didn't carry 1. We carried one set of the base, because it became 100. For it to have become 100 is because it must have been 10 tens. So we carried a set of the base. So when we come now, and let's say we do that directly now, if we were to say 136 and you rather go direct to 99, we'll say this is 15, carry one set of 10. Now this is 3 plus 9, that's what? 12. With that set of 10 we carried over, that becomes what? That becomes 13. We carry one set of 10, because it's now 10 tens. 10 tens will give us what? 100. So we're on the hundreds column here. 1 plus 1 gives us what? 2. So what I need to highlight is when we carry we carry that sounds repetitive. We carry, that sounds tautological, but then when we carry a set of the base. Okay, that's the punishment we get for English not being our first language, right? So when we carry, it's a set of the base that we'll be carrying. Okay, so that is very important information. When we master this understanding, it will be easy to do addition in any base. I'm gonna do addition because our primary target there is what? Is binary addition. So later though, I will make an example with what? With another base, just to show you that this is a standard for every base. All right, so I will then say, okay, let me possibly see if we like. If there's anything that people have questions on here, they can think, but I'll then move on to what? I'll then move on to binary addition, because what I'm doing is binary addition, but I'm trying to take you back to what? To decimals, what we can understand what we're doing. What I'm going to do in binary is, well, once we understand this concept, every other base will just be what? A cruise, a walk in the park. Let's start a fresh page here and say, okay, I will do binary addition now. With binary addition, not the addition, not this addition, but putting things together. Addition. Well, it is an addition of binary addition, but okay, so let's just do binary addition. What do we see? Let's take a number. I'll immediately go to something with commas. 101, 111, with 11, 101, with 100, 1011, and finally 1001, 1, and I say add these numbers, and these are my binary numbers. They are all in base 2. Right, so I will first start. Before I put the little base 2, what I like to ask students to do is to balance up the number of digits. We've got 4 decimal points here. Let's make them all 4. Adding, I want to highlight again that when you add after a comma, when you add zeros after the number after the comma, then you won't have changed the value of that number. What do I mean here? 2, 1 if I add a 0 here, I won't have changed the value of the what? Of the number. Just as much as if I add 0 before the whole number, if I say 2, comma 1, I still didn't change what? So adding zeros before the number and adding zeros after the comma. Remember, you can't do that with 21. You can't add this because it becomes 210. Okay, so but what you can do is, if it's 21 and there's a comma, you can add as many zeros as you want. Okay, this is what I'm trying to highlight here, and you don't change the what? The value. As long as after the comma, after the number, you can add zeros without changing the value. This is what we did here. Okay, we did it once here, we did it once here, we did it 3 times here, we still didn't change any value. Now before the whole number, we can add zeros also without what? Changing the value. So we can do anything if as long as it doesn't change the value. It's just the inconvenience of writing. Now I can put my little tools to show that it's actually binary numbers. Okay, sorry, I think I must remove this. Not wrong choice of rubber, that will take us forever. Remove this whole thing. Now also I would like to make this a little bit shorter. Now when you look at this, the 1 has got nothing to add to, so our answer there is 1, and I immediately put my little 2 because it's very easy to end up forgetting it. Now 1 plus 1 plus 1 is 3. So 3, but that 3 is what? Is me when I'm doing it. That answer is me when I'm doing it in decimal. But what is 3 in binary? We have done this already. We know you divide by the base. So this is 1 remainder 1, 0 remainder 1, and we take our answer up, and therefore our answer is actually 1 1. But we put only the last one, the least significant one. The other one has been promoted to the what? To the next line, because our answer is actually 1 here, but there's other things to add to, so I'll put it in the air for the time being now. But what have I carried there? I did not carry 1. I carried 1 set of the base. Okay, I carried 1 set of the base. Let me first clarify something here. All right, I'll come back to that. 1 plus 1 will be 2. Again, 2. How do you get 2? 2 into, because our answer, we're doing the addition we're actually doing the addition in decimal, and then we have to write our answer in what? In binary. So 1 plus 1 is 2, but our 2 in binary is what? 2 there is 1, remainder 0, 2 there is 0, remainder 1. Taking it up, our answer is 1 0. Okay, then now we've got 1 plus 1 plus 1 plus 1 plus 1, that's 5 ones, so our answer is 5. So you would think it's 5, but you can't have 5 in binary. What do we do? Convert that 5 into binary, and it's what? It's 2 remainder 1, 2 there is going to be 1 remainder 0, 2 there is 0, no, what am I doing? 0 remainder 1, and we take it up, and our answer is not on this column, on that column. So binary has got this unique thing where you can actually carry over and actually jump a few columns. So our 1 is here, there is 0 there, okay, then there is a 1 here. Okay, we only write the final one. So this is a 0. If I put it as a blob, it might end up confusing me to think it's a 1. It's actually a 0. So this is 1 0 1, which is what 5 was. Now we come to this column here. There was a 0 here because the other one actually jumped this column. So it's 1 plus 1 plus 1, which is 3. We've done 3. We know it's 1 1. You can refer back there. It's 1 1. Our comma stays in this space, so it's 1 1. So now you see, with another unique thing about binary is that you can have a lot of carries in the one space. We've got 2 carries now in this one space. 1 plus 1 plus 1 gives us 3. Again, it's 1. It's 1 1. 1 plus 1 plus 1 is again 3. 1 1. 1 plus 1 becomes 2, so it's 0 1. Because even if you carry there, there's nothing to add to, so we can being as careless as some of my students, the 0 must be in what? The 0 must be in line with the other column, and then our 1, because remember it was what? 1 plus 1, it was carry 1. That 1 is nothing, so I can put it down. So this here is our answer, doing this in what? In binary. So The whole point is when we carry, we are carrying what? A set of the base. Right, I will want to do, I don't know whether this is this, I try to do a number that is already what? That is already a little bit long, to try and make this as clear as possible. We don't want to keep doing this. We don't want to keep doing this. It is very irritating to keep doing this. So these numbers have to start what? Registering in people's minds so that you are much faster. We can't keep doing this. I'm doing this because I'm trying to illustrate, but otherwise I wouldn't really have to do this. I know my 3 is 1 1. I know my 7 is 1 1 1. At some point, you need to be so fast and flexible with your binary that you don't have to what? Don't have to keep doing this. Yes, for now, until you get used to it, yes, we can keep doing it. But further on, I will not be doing this anymore. If you can't follow, pause the video and go and do it on the side for yourself. Because the more you do it, the more you'll be as flexible as I and a lot of other people are. So I will now do another example without necessarily having to do this. Just let me do it right there. I will say, okay, let's take an example. Let's make it simple. 1 0 comma 1 1 plus 1 1 comma 0 1 plus 1 1 0 1 comma 1. Okay, remember, first thing, balance up your digits and make sure that your columns are nice and straight. So we know our comma is going to be there, because our comma is also has to be aligned. These are binary numbers. I really think it's good practice to always have your little 2. Now then you say 1 plus 1 is going to be 2. Now I said I will not be doing that again, so I'll just write my 2 as what? As 1 0. Now I go to the next column. The 1 plus 1 plus 1 is going to be 3. I know it's 1 1. It's actually 1 1. I go to the next one, is also 3, so my answer is going to be 1 1. Answer is also 3, 1 1. Answer is 2 1 0. Why? There's nothing, as I can see, there's nothing else there that is going to challenge that one. So remember, we are adding here. All right, so there is our what? Is our final answer. So I don't know whether I think what have you seen when we added, when we added 0 and 0, 0 and 0 would have given us 0, right? Obviously, we know that. So, in fact, let me summarize. Let me go to another page and summarize our addition here. What I'll do is I'll summarize, and then I'll say, okay, let's summarize. This is the summary. Okay. In summary, when we add, we will say 0 plus 0, 0 plus 1. I'm trying to do the combinations 1 plus 0 and 1 plus 1. Know something here. This is the count 0 0 0 is the count 0. This is the count 1 0 1. This is the count what am I doing there? 2, because this is what? 1 0. And this is the count 3. The door banging there, my door banging there sort of shook me a bit and took me out of my concentration for a second. So it's a bit of a windy day. Now, why is this relevant? Is you can see that this count here has been done in order of the decimal count. It is best practice to do that, because you get much longer combinations where you have to add more things, and if you follow the count, it's very unlikely that you will skip what? You might skip any combination. So remember, the combinations, the number of combinations, let's say the number. What do I mean? We combine the 0 and the 0. We combine the 0 and the 1. Combine the 1 and the 0. Combine the 1 and the 1. So the number of combinations, of possible combinations, because I wanted to say possible, I will say possible combinations. Yeah, maybe it will stick out if I put it on its own. A number of possible combinations is given by, given by, let's call the number of combinations. It is given by 2 to the power of n. Okay, where n is the number of bits. Okay, so what do you mean here? We've got 2 bits here, 0, 0 and 0, 0. We're adding only 2 bits, so we have 4 combinations. Those 4 combinations are from 0 to 3. The count is 0 to 3. All right, the number of combinations is given by what? That's by 2 to the power of n, where n is the what? Where n is the number of bits. 2 bits will give us what? E.g., in our example, number of combinations is given by 2 to the power of 2. Why? We've got 2 bits. Okay, this refers to the 2 bits. Okay, the power is the 2 bits, and therefore we've got 4 combinations. This is the count 0, 1, 2, and 3. Okay, we can't forget 0. Okay, so the number of combinations given by what? Please be careful. That is actually what? A test or exam type question. All right, so let's see the addition here. When you add 2 bits, 0, 0, the count 0 will give us 0. 0 plus 1, everywhere you go, that will be 1. 1 plus 0 as well, that will be 1. All right, now if you look at this one here, the number of combinations is what? Is 4. This is our 4th combination, the count 3. And if you say 1 plus 1, you say 1, but we say we have to carry. Oh, what am I doing? Sleeping again. 0. Our answer is 2. Remember, our answer is 2. Okay, but we are not going to do this. We are going to say this is the carry. So we are going to what? We're going to move the carry and we write it on its own and say our answer is 0 carry 1. What is this? 1 set of 2. So 1 set of the base. I need this to be very clear. When you carry, because when you go to what? When you go to subtraction, we are going to be borrowing, and again you will see we are going to be borrowing a set of the base. But we'll come to that. So when you carry, we are carrying 1 set of what? 1 set of the base. I know this is gonna come later. I normally want to take care of my well, I know what tends to come in thing. Having taught for about 21 years now, I know what will most likely come in future scenarios. So now what I'll do is I'll just to wrap this in. I'll take another scenario, and I'll say, okay, let's possibly what? Let's see. It's just an extension of that. It's just an extension of that. Let's see what happens if we say, okay, we deal with what? With 3 bits. What happens with 3 bits? We saw how with 2 bits, in our previous example, with 2 bits. Oh, sorry about that. With 2 bits, I hate to look clumsy. With 2 bits, what happened? Number of combinations was 2 to the power of n, which was 2 to the power of 2, and it was 4. The count 0, 1, 2, 3. So we had 0 plus 0 equals to 0. We had 0 plus 1, which is the count 1, equals to 1. We had the count 0, 1 plus 0, which is the count 2, and we had 1. And we had 1 plus 1, the count 3, and we had our what? Our 0 carry 1 set of the base, and you just say carry 1. All right, so 3 bits. So 3 bits would mean number of combinations is equal to 2 to the power of n, but in this case 2 is equal to 3, and then not 2 is equal to 3. The number of bits is 3, n is equal to 3, and this is 8. Okay, combination. So it will be the count 0, 1, 2, all the way up to 7. So this will be 0 plus 0 plus 0, the count 0. Okay, 0 plus 0 plus 1, the count 1. 0 plus 1 plus 0, the count 2. 0 plus 1 plus 1, the count 3. 1 plus 0 plus 0, the count 4. 1 plus 0 plus 1, the count 5. 1 plus 1 plus 0, the count 6. 1 plus 1 plus 1, the count 7. Remember, this is 4, 2, 1. So this is a 1. This is a 2. This is a 2 and a 1. This is a 4. This is a 4 and a 1. This is a 4 and a 2. This is a 4, a 2, and a 1. So this was the count 0, 1, 2, 3, 4, 5, 6, and 7. So now 0 plus 0 plus 0 will be obviously what? 0. 0 plus 0 plus 1 will be 1. 0 plus 1 plus 0 will be 1. 0 plus 1 plus 1 will be 1 carry. This is 2, sorry, this is some 2, so 2 is 0, 1, 0, not, so it's actually 0. I'm getting carried away. This is actually 0 carry 1. Why? Our answer was 1, 0. So this is 0 carry 1. We are carrying 1 to the next column. Okay. This here is 1 plus 0 plus 0 will be 1. 1 plus 0 plus 1 will be 2, which is the same as the previous case of a 2. 0 carry 1, because the carry normally sits to what? To the left, to the immediate left. That will therefore be 1, 0, which is our 2. Same here, our answer is what? 0 carry 1, because it would have been a 2. But in the final case, our answer is a 3. This will be 1 with a carry of 1. This is very important. This is our what? When you are doing 3 bits. We could do a scenario with 4 bits. I think I'll leave that to the students to practice and see if you are what? If they are actually as flexible, or as, I'd like to say, if you have to be flexible with this, you have to be more flexible with this. So I think when it comes to addition, I've done as much as I can, and I think hopefully if there's questions, I'll receive them, and I can be able to assist. All right. Other than that, I think it's time for me to say this was probably the longer than thing. There were a few mistakes here and there. I hope we didn't really confuse people here and there. Thank you. Let's see how this helps. We'll meet again when we're doing the what? When we're doing the subtraction.